Hello everyone, welcome back to our polynomials unit. We are going to be talking about multiplying polynomials in this video. If you have not played with algebra tiles yet or have done adding polynomials, subtracting polynomials, highly advise that you take a look at those two videos. So, looking back in multiplication, as we always do, 3 times 4. We know it's 12. But I'm going to make a field for you to represent our 3 times 4. So we're going to have 3 times 4. And this is going to make a product. It's going to make 3 sets of 4 or 4 sets of 3, depending on how you look at it. So here's our 4 sets of 3 or our 3 sets of 4. So it makes a field or a product of 12 boxes. It should say squares. -2 times 5. Now it doesn't matter what side I actually set up the -2 on, as long as it just fits. I designed my box to fit it. So we have -2 sets of 5 or 5 sets of -2. Now I color-coded red for negative. When we have red times a blue, or negative times a positive, you're going to get a negative. So that's why we have a red box here. So it makes a product of -10 boxes. So -2 sets of 5 gives you -10, or 5 sets of -2 gives you -10. 3 sets of x. All right, so this is the whole point of this lesson here. We are going to be representing polynomial expressions, so variables. So 3 sets of x is going to give us what? Well, it's going to give us 3 x's. Done. So I know that seemed dry. You've done this before many times. But we're warming up to it. You'll see. So 2x times 4. So I'm creating a product field here. There's a tool that we're going to be using for the first while. Some students love it and use it for a little longer than that. It works really well for whole numbers and small numbers, but you're going to have to get rid of it at some point. So we have 4 sets of 2x. That's going to create how many x's? 8, right? You have 2 x's, and you have that 4 times, so 8x. You have 2 x's and 3 x's, and you have 2x sets of 3x. Whoa, that sounds a little confusing. Let's see what happens here. So we have 2x and 3x. Now take a look. It fits. X times x gives us an x squared, right? It fits perfectly. It's like a puzzle piece. It's going to give us how many x squareds? 6x squared, which makes sense. If we are distributing here or rearranging things to the commutative rule, we got 2 times 3 times x, which gives us 6x squared. Right? I just rearrange my terms as I can. Now, more multiplication here. So 2 sets of x minus 1. So here's my 2, and I want to make another set of x minus 1 right here. So x minus 1. And we're going to multiply. So 1 times x is going to give me x. 1 times x is going to give me x. 1 times -1 is going to give me, let's find out, -1. And another -1. So what's my answer here? It's going to be 2x minus 2. Let's try this one, -2x times x plus 2. So there's our x plus 2. And there's our -2x. Okay? So it's like a puzzle piece again. You can see my x length times my x length is going to create a square. And then my x length right here times my 1 length gives me a rectangle. We can fill those in. Now they're all red because negative times a positive is going to give me a negative. So we have negative 2x squared minus 4x. 3x times 2x minus 1. Let's take a look. There's our 2x minus 1. And there's our 3x. So just like a puzzle piece, you can see what fits, right? X times x, and then x times 1 here. Fills in. So we have 6x squared minus 3x. Multiplying without algebra tiles. So I've taught you how to multiply with algebra tiles. It's kind of annoying to multiply without them. I'll show you why. So this is saying 2 sets of x minus 1. That's what multiplication of is. It's sets of. So we have 2 sets of x minus 1. Just like adding polynomials, we're going to break down those brackets and see how many x's we have and see how many 1's we have. And I see 2 x's and I see 2 negative 1's, so 2x minus 2. Now that can be annoying in some situations like this. 10 sets of x minus 2. Well, let's write down 10 sets of x minus 2. Now, that's annoying, also takes up a lot of paper, so we're not going to do it that way. We're going to use a distributive property. Good times. So we're going to multiply the 10 in, because there's 10 sets of x, and there's 10 sets of negative 2. So we're just going to multiply it in. When we say sets, it just means multiplication. So you have 10 sets of x, and now 10 sets of negative 2. It looks like this if I continue to show my work. And we got 10 times x is going to be 10x, and 10 times 2 is going to be 20, and we have that negative sign there, so negative 20. Simplify the expression below. So in this page here, I'm going to show you how to solve it with algebra tiles and without algebra tiles. So with algebra tiles, we have our 3x minus 1. We have our negative 2x. Hope you got something similar. Now without algebra tiles, so we should get, if this is true, we should get negative 6x squared plus 2x. Let's find out. So we're going to distribute our negative 2x into our 3x minus 1. So now we have negative 2x times 3x. And we have our negative 2x times 1. Multiply those out. And we have negative 6x squared minus negative 2x. Remember, if you're ever taking away a negative, that's a happy thing, right? If you're in debt, if you have negative $5 and I take away negative $5 from you, you're going to be pretty happy. It's like you gained $5. So that's why this becomes a positive. So we get negative 6x squared plus 2x. Same thing. So now we have a way of representing it with algebra tiles and a way without algebra tiles. Now this is going to be your method as we move forward in math, because this works well with whole numbers that are low, but this works with all our numbers. So let's go through a couple examples together. Feel free to pause the video and try it on your own. So I'm going to distribute my 2x into both of those. Beautiful arrows. Thank you. All right, so 2x times 3x minus 2x times 4. So 2 times 3 is going to be 6. X times x is going to be x squared. Negative sign still there. We're subtracting this term. So 2 times 4 is 8, and our x is just going to sit there. We don't know what it is yet. Negative 3m times this whole expression, 2 plus 4m. Distribute. So now we have negative 3m times 2 and negative 3m times 4m. Okay. Now I'm saying don't forget standard form, because you're going to see here negative 3m times 2 is going to be negative 6m, and negative 3m times 4m is going to be negative 12m squared. Now standard form will require my highest degree term, that exponent 2, its higher than this exponent of 1 to come in first in our order. Standard form is just a good method of showing our end results here. It's nice and organized. Also keep note that the negative here sticks with the term, right? This is a negative 6m, so it follows. It's still a negative 6m. All right. So now we have multiple terms here. We have 3 terms. Same thing. There's 2 y sets of all of these. So you multiply that 2y in. So we now have 2y distributed to each term. So we just multiply it out. So 2 times 3, we're going to get 6y cubed here, minus, we're going to get 8y squared, and plus, we're going to get 2 times 2 is 4, and the y is just chilling. Excellent. Some more examples. I'm throwing in a couple more variables this time to show you how I play with it, or how you should play with it as well. So we're multiplying this whole term into our expression here of 3x minus 4, so it appears twice. And let's see, we got 2 times 3. So 2 times 3 is going to be 6. We have an x times an x. It's going to be x squared, and then we have a y left over. Taking away this whole expression here, we have 4 times 2, which is 8. And then we have our yx. I'm going to organize it as xy, just so it looks similar to that term here. It's like, it's art, you know, you got to make it look nice. See, I did the y first here to make it look nice. All right. So notice the variables multiply each other. They cannot actually combine, right? We don't know what y is. We don't know what x is. So they stay separated. Negative 3y, we're going to multiply that in. So I'm going to get negative 15 here, right? Negative 3 times 5, y squared, minus, now I'm putting a bracket up because I see I have a negative term coming up. I'm just keeping it organized at the moment, 3ym, because the m multiplies in. Now remember, when I have 2 negatives, if I'm taking away a negative, you're stoked on that, you're very happy. Take away the negatives, please. So it becomes a positive, it's like you gained it. So you have negative 15y squared plus 3ym. All right. We're going to distribute again. So we have 8m sets of each of these terms. Okay. Now, some people would shove the negative in with the 4 and make it look like this. That is up to you. I'll show you. Plus 8m bracket negative 4n. So they instead put the negative and kept it with the 4. That is okay. It's the same thing. It'll give us the same answer. You just multiply 8 with negative 4 instead of 8 with 4. So 8 times 7 is going to give us 56. M times m is m squared, minus 8 times 4, 32. Same thing, right? 8 times negative 4 gives us negative 32, times m times n, plus 8m times 3, which is 24. So a classic question I'm going to give you is you're going to have an area to find. And you don't know what x is yet. So you need to find an expression to represent the area. So don't forget, area for a rectangle is base times height. So that's what we did. We're going to take our base, our 3x minus 1, and our 2x, our height, and find an area, a product, right? So we distribute it in. So now we have 6x squared, right? 2 times 3 is 6. X times x is x squared, minus 2 times 1 is 2, and then x just is hanging out there. Then I would extend the question. I would say, well, let's assign x a value. So now we have an expression to represent the area. What is the area of x is 4? Once you have an expression, it's an easy plug and play. You just plug in the numbers here, and you solve it. So 4 squared is 16. 2 times 4 is 8. 96 minus 8. And 88. So if the x was 4, our area would be 88 meters squared if this was 4 meters. Did not specify that. Okay. If there are any questions, you can feel free to comment in the section here or email me. That's up to you. That is multiplying polynomials. In our next unit, we'll do some similar techniques to learn about dividing polynomials. Thank you for tuning in.